So yesterday we went over substitutions. Remember that it literally just means to substitute one equation into the other. Today we're going to go over elimination. And again, it's based on its name. Our goal here is to eliminate one variable by combining the two equations. Okay, and then just like yesterday, there's going to be a list of steps we need to follow to do that. So our first step is going to be to make sure that our equations are in standard form. Which, remember, is that form ax plus by equals c, where a and b can be any coefficient for your variables x and y. All right, once you've made sure that both of your equations are in standard form, then we need to work on trying to get one of those variables to eliminate. In order for that to happen, you are going to need one or both equations so that one of those variables has the same coefficient but opposite signs, so that when we put them together, one of them will eliminate. So we might have to manipulate one or both equations so one variable has the same coefficient but opposite sign. So, in other words, maybe if we're trying to eliminate the x's, we might need one of those to have a coefficient of 3, and then the other one would have to have a coefficient of -3. All right, once you've made that happen, you then are going to combine your equations by adding like terms. At this point, you should have a variable that cancels or that eliminates. If you don't, then we need to go back and look at how we manipulated our equations. All right, once one of your variables has been eliminated, you're going to solve for the remaining variable. And once you've found one of the variables, just like yesterday, you just take it, substitute it back into an original equation so that you can find the other. So plug in answer to an original equation. Make sure it's an original. To solve for the second variable. Also, make sure at the very end we do go back and write our final solution as an ordered pair. Okay, so now that we have all of our steps written out, let's give it a try on a few examples. Okay, on number 1, our two equations are going to be 3x minus 4y is equal to 13, and 2x plus 4y equals 2. All right, so our first step, we said, is to make sure that our equations are in standard form. Are these in standard form? Yeah, okay, so we're good to go there. All right, second step was to manipulate one or both of the equations to make sure that you have one of those variables that has the same coefficient, so same number, but opposite signs. Are we going to need to do anything to make that happen, or is it already there? Already there. Okay, so then we move on to that next step, which is to go ahead and combine our equations by adding like terms. So I'm going to add these two equations together, but we can only combine terms that are like. So for my x's, we've got 3x plus 2x, which would give us, good. And then we have negative 4y plus 4y. It's gone, right? Just 0. There are no y's left. So we did have something that eliminated, which is what we wanted. And this is equal to 13 plus 2. And now we just need to solve for this variable. So what is x? 3. Okay. All right, now we just need to solve for y. And we do that just like yesterday by going back to these two original equations and picking one of them to substitute that answer back into. Would you guys prefer we use the first or second? Second? Okay, we can use the second. So the second would be 2, but we replace that x with what we now know to be 3, good, plus 4y equals 2. All right, so what am I going to do first here? Good. All right, what should we do next? Subtract the 6. Good. So we'll have 4y would be equal to negative 4. Therefore, y must be negative 1. And then make sure we write our solution as an ordered pair. So our solution would be negative 1, right? Okay, and then just like yesterday, remember you can always check your solution by substituting back into either one of those original equations. So if we used that second equation again, it would look like 2 times 3 plus 4 times negative 1 equals 2. So that 2 times 3 we said gives us 6. And 4 times negative 1 is negative 4, right? And is 6 plus negative 4 equal to 2? So our checks work. We are good to go. Okay. Look at another one together. For this one, our first equation is going to be x minus 3y is equal to 5. And then the second equation is going to be negative x plus 5y is equal to 7. All right, are these in standard form? Okay, so we're ready to try and eliminate a variable. Do I need to change anything about the equations? Okay, so we go ahead and add. What's going to happen with those x's? Good. And what are we going to get for y? 2y, good. Is equal to, well, nice. So y must be, very good. All right, and then remember to solve for x. We go back to our originals. We pick one. You guys want to use first or second? First, okay, so we would have x minus 3 times, we replace that y with what we now know to be 6 equals 5. What is negative 3 times 6? Is equal to 5. So what is x? And then just make sure we go back and write that solution as an order here. So this time, 23/6, right? And again, you can always go back, substitute that information in. If we use that same equation, we'd have 23 minus 3 times 6 equals 5. We already said this was 18, and 23 minus 18 is going to give us 5. All right. Okay, let's flip it over onto that last page there. Okay, number 3, our first equation is going to be y equals negative 3x plus 8. And then our second equation is going to be y equals 3x minus 4. Okay, so right now these equations are not in standard form, right? The reason that we typically want to put them in standard form is because we need our variables to line up and we need our constants to line up, right? In this particular case, you don't necessarily have to rearrange it because everything is lined up, but you are always welcome to rearrange into standard form as well. If we chose to leave it as is, do we have to manipulate our equations to make anything eliminate? Okay, so it would be okay if we just want to leave it as is, because if I go ahead and add these as they are, y plus y would give us 2y is equal to, what's going to happen to our x? There we go, and then 8 plus negative 4, 4. So y would be 2. So again, the reason we were able to leave this in the form it was written is because everything was lined up. If it's not, then you do have to rearrange, okay? All right, so we got y, now we need x. So we need to go substitute back into one of these originals. Which one should we use? Second, okay. So we'll have, in place of y, 2 equals 3x minus 4. What are we going to do first? Add 4, good. And then we get that x is 2. Okay. All right, so our solution for this one would be the coordinate 2, 2. Okay, I want you guys to give number 4 a try. I'm going to write the equations up here for you and then give you a second to work it out. And then we're going to check our answer together. So we have 2x minus 3y is equal to 19. And then we have negative 2x plus 3y equals 21. Okay, so I'll give you a second to look at that. the correct solution, what happens? Very good. When we added these together, the x's gave us 0 and the y's gave us 0. So we ended up with 0 on that side of the equation, right? Is equal to 19 plus 21, which is 40. But is that true? Does 0 equal 40? Okay, and so since we ended up with a false statement, we know that there would be no solution here. Very good. So, no solution, which we can always use the notation for here, which denotes it in 2 cents. Okay. Okay, so obviously there's a few special cases that can occur where we don't always get that nice coordinate point answer like we're used to seeing, right? So let's talk about those. Let's say that you get, we'll make a little chart. You get a certain solution, and we're going to talk about what that solution would look like on a graph. Okay. So let's say that whenever you solve, you get a coordinate point answer, some x and y value, okay? What would that look like if you were graphing those two equations? What would you see? Two lines that do what? Intersect, right? So the graph here would be two intersecting lines. Okay. Let's say we end up with something like we did here, a false statement, like 2 equals 3, or maybe even 4 equals negative 4, right? Those are not true statements. In that case, we know that that means that we have no solution. What would that mean our lines look like on a graph? Parallel. Parallel, very good. This would mean we have parallel lines. This is a symbol that denotes parallel. All right, and then the last possible outcome would be maybe something like up above, where we do have all of our variables zeroing out, but maybe the other side zeroes out too. So we're left with a true statement. So maybe something like 0, 0. Or maybe we have constants on both sides, and we end up with like 4 equals 4. In this scenario, what would our graph look like? The same line. Very good. So in this case, we must have the same two lines. They would be graphed right on top of each other. And in this case, we had no solution. In this case, what would my answer be? Anybody remember what we say when they're the exact same line? If they're the, what? Not 0. If they're the same line, did they just intersect at one spot? No, they're right on top of each other, right? So they intersect at every single spot on that line. If those lines are continuous, infinitely many solutions. Very good. Okay. Okay, let's do another example here. Let's say that we have the equation 3x minus y equals 8 and x plus 2y is equal to 5. All right, if I was going to solve these using elimination, are they lined up? Do we have everything there in standard form? Okay, so they are in standard form. We're good there. But if I add them right now, is anything going to eliminate? So that means we have to manipulate one or both of the equations. Typically, if we look ahead, it's usually easy to change one particular variable and maybe harder if you're changing one of the others, depending on what the coefficients are for everything else, right? Okay, so I could do something to fix the x, or I could do something to fix the y. Let's say that we want to try and make our y's eliminate. If I want the y's to eliminate, how could I manipulate one of my equations? Yes. Perfect. That's exactly what we want to do here. So I'm going to multiply the entire first equation by 2. If I multiply that first equation by 2, what does it become? Very good. All right. And then we're not going to change anything about that other one. So I'm just going to rewrite it as it was, right below it. And now if we add, we should have something eliminate. So what do we get when we add those x values? Good. And what happens to those y's? Good. And 16 plus 5 gives us, good. So x must be, very good. Okay. So we solved for x. Now we just need to find y. So remember, we can go back to these original equations and substitute into either. You guys want to use the first one or the second one? Second, okay. So in place of x, we have 3 plus 2y equals 5. So we're trying to solve for y. We need to get rid of that 3. And we subtract. We end up with 2. So y must be 1. So this would mean that our solution here is the point 3, 1. Okay. Okay, we have one left, and we're going to do a word problem together here. It did not print the word problem on y'all's notes, did it? Okay, that's okay. I'll just read it out loud for you guys. It says that 2 families go to a hockey game. One family purchases 2 adult tickets. I'm going to write that part down. One family buys 2 adult tickets and they also bought 4 youth tickets for $28. Okay, there's also another family purchasing tickets. So another family purchases 4 adult tickets and 5 youth tickets. All right. So, for $45.50, sorry. Okay. And we are going to figure out how much an adult ticket and how much a youth ticket would cost based on this information. So in order to do that, we need to write a system of equations. That means I'm going to write how many equations? 2. So we got to have 2. Okay, so based on the first bit of information, one family purchases 2 adult tickets and 4 youth tickets for $28. We need to come up with an equation. So the first thing I'm going to do is define my variables. So we're going to use x and y. So x is going to represent the type of tickets they mentioned first, which was adult. And then y is going to represent the second type, which was the youth. Okay, so now that we know what our variables are going to represent, we're going to go ahead and write our system of equations. Can anybody tell me what that first equation should be based on the information given? Good. 2x plus 4y is the tickets they bought, and those tickets cost that family how much? 28 equals that $28. Okay, now we just need a second equation. We can use the second family's purchase to come up with that one. What would that equation be? Very good. Okay, all right, now we need to solve. Okay, so if we're going to use elimination to solve this, we need a variable that's going to eliminate. Right now, that wouldn't happen, right? So any ideas on how we can manipulate one of our equations to make that happen? Awesome. We're going to multiply this entire first equation by a -2. Okay. So if I multiply that first equation by -2, what does it become? -2 times 2x would give me, good, -2 times 4y would give me -8y, good, and 28 times -2 would give us -56, good. And we're not going to change that second one, so we're going to leave it as is. Okay, so now we did fix it, something will eliminate. Let's add these together. Those x's will now eliminate. What happens, or what do I get when I add the y's? Good. And what do I get when I add -56 and the 4550? I'm sorry? Okay, yeah. So whenever we are dealing with money, guys, don't be freaked out if you get a negatives here, because remember, when we start to divide the negatives, what's going to happen? When you divide a negative by a negative, what happens? A positive, right? So don't freak out whenever you see that, because I don't want you thinking that it's not going to work out. It's going to work out. Okay, so what did we say that we get? Not 11, 10. So -1050. Okay. All right, and then we are going to divide by that -3, which we said works out for us because we can't have negative money, right? So whenever we divide by -3, what do we get for our value of y? Good. Okay, and then if I want to find the value for x, I would just take this and substitute it back into one of these originals, right? You guys want to use that first one or second? Up here. The first one with the 2x, is that what you said? Yeah. Okay. All right. All right, so we would have 2x plus 4 times y, which we now know to be 3.5. Good. Is equal to 28. What is 4 times 3.5? And then we would have 2x plus 14 equals that 28. And then we will subtract and divide, right? So what would our value of x be? 7. Okay. So typically, remember, we do write our final solution as a coordinate point, but here we actually have some context as to what this is supposed to be representing, right? This is the cost per type of ticket. So you also could say how much each type of ticket costs. You could say that the adults cost how much? $7. And youth cost, good. And typically, if it's a word problem, you're answering a type of question as to what belongs with what value. So we'll see our answers written this way.